Hello everyone, welcome to this video to understanding Parser Generator. Introduction to Parser Generators. Parser Generator, which are tools designed to create parsers, programs that analyze and process structured text such as programming code or data files. Instead of writing parsers manually, these tools automate the generation of code that understands and interprets various input languages, saving both time and effort. Parser generators are widely used in software development, especially in compilers, which translates source code to machine code, interpreters, which directly execute code, and data format converters, which transform data between different formats. What is parser? A parser is a key component in language processing. It is a program that takes input in the form of sequential data like source code and analyzes it. The parser then converts this input into a structured format. Typically, a parser tree or an abstract syntax tree. This structure represents the hierarchical syntax of the input, making it easier for other tools like compilers or interpreters to understand and work with the code. Types of parser generator. There are two main types of parser generators. First one is top-down parser generator and second one is bottom-up parser generator. Top-down parsing. The parser starts from the start symbol, which is the root of the grammar, and works its way down the leaves, trying to match the input with the grammar rules. And bottom-up parsing works in the reverse direction. It begins with the actual input and gradually builds up to reach the start symbol, reconstructing the higher level structure as it goes. Popular parser generators. These are tools that helps us building parsers for different programming languages and purposes. First, we have ANTLR, which stands for Other Tool for Language Recognition. ANTLR is widely used today because it supports multiple target languages like Java, Python and JavaScript. Next, BISON, a powerful parser generator primarily used with C and C++. Its successors of YACC and offers more flexibility and features, make it ideal for performance critical parsing. YACC, which stands for yet another compiler. It's one of the oldest parser generators and is still in use today, especially in Unix systems. How popular parser generators work? Parser generators use formal grammar as an input to define a language's syntax rules. Based on this grammar, they generate source code for parsers in target languages like C++ or Java. The resulting parser can then analyze and interpret input code or text by following the defined grammar structure. Grammar definition. A grammar is a set of production rules that defines how statements in a language should be structured. Each production rule in a grammar defines how symbols like keywords, operators, or identifiers can be combined to produce valid string or expression. Among the different types of grammars, the most widely used in parser generation are context-free grammar or CFGs. These are popular because they are simple to define, easy to process, and powerful to describe the syntax of most programming languages. Advantages of using parser generators: saves time, automatically creates parser so developers don't have to write all the code manually, reduces errors, less chance of making mistakes compared to writing the parser by hand. Challenges in parser generation: ambiguity in grammar. If the grammar is ambiguous, the parser generator may not know how to choose between multiple valid parses. Left recursion is a typical program for some parser types, for example, LL parser, requiring grammar rewriting. Use cases of parser generators: domain specific languages DSLS creates specialized mini languages tailored for specific tasks, for example, configuration languages, query languages. Compiler and interpreter constructions: parsing source code written in programming languages like C, Java, Python. Example tools: ANTLR, YACC, and BISON. These are the tools. Conclusion and future trends. Parser generators have been crucial tools in automating the creation of parsers from formal grammars, significantly simplifying the development of compilers, interpreters, and many other language processing applications. They reduce manual coding errors, improving maintainability, and accelerate language tooling development.